Hello and welcome to Mostly Weather. My name is Jeff Norwood-Brown. The other day, looking out the window, I noticed a jet going by incredibly fast towards the south coast. I looked the aircraft up on an app, because of course I did. It was travelling 546 miles an hour, which is pretty fast for a passenger jet. So I knew it must have been in the jet stream, and that jet stream must be flowing north-south across the UK that day. And I only knew this because of my work at the Met Office, and that got me thinking, what weird facts do me and my colleagues know because of where we work? Joining me today, our custodian of weather history and archivist who doesn't like snakes, it's Catherine Ross.
Hello, Jeff.
Operational meteorologist, seafarer and extreme weather advisor, Penny Tranter.
Hello there, Jeff.
And broadcaster, meteorologist and innovator of products, Helen Roberts.
Hi, Jeff.
We've all been challenged to bring to the table several weird facts we think you may not know. So let's start with witchcraft. Catherine.
Thank you, Jeff. So, did you know that weather forecasting was outlawed as a form of witchcraft and sorcery by Henry VIII? That's because it involved looking into the future. What the weather might do was one thing, but if you could do that, you might also be able to look into the future of the king. That was a rather less popular idea. What's slightly more interesting is that the Witchcraft Act wasn't fully repealed until 1951. The Met Office was founded in 1854, and I'll let you do the maths.
So, I think the last witchcraft trial was in the 1950s.
Maybe it was Forecaster.
Yeah, well, yes, I could imagine it would be. And one of the facts I've got as well is that up until very recently, we used crystal balls to do the forecast in the form of Campbell-Stokes sunshine recorders. Does anybody remember a Campbell-Stokes? So
we still have them come into the archive. They're still in use.
They're still around,
yep.
Yes. And much sought after, I have to say. But these are just look like a crystal ball in a cradle, which would focus the sunlight as it travelled around the sky, burning a piece of cardboard. And then you could take the cardboard out at the end of the day and then count how many hours of sunshine we had. A little bit more sophisticated, but not as elegant these days. And we just use electronic equipment to measure sunshine. But that's how it was done for quite some time.
I still remember that lovely smell of the
charred
slightly
cardboard.
charred cardboard. Yeah, counting up how many hours there'd been.
I thought they were absolutely fantastic bits of kit until
They
I
are.
tried to get the cardboard out one very, very rainy night in the Falkland Islands when it was blowing a gale. And yes, it was just falling apart in my hands, So fortunately, there wasn't much sun to count that day. The other mysterious thing I've got is a Brocken Spectre. Are we all familiar with a Brocken Spectre?
Yes.
So this is an image that you can see when you've got fog or low cloud around. It's similar to a glory that you might see from an aircraft, which looks like a small circular rainbow around the shadow of the aircraft that you're in. But the Brocken Spectre is something that walkers quite often see, and it's their own shadow projected onto the fog or cloud bank or whatever. And it looks enormous and has a halo around it as well. So that's, it comes from, Brocken, I think, is a mountain in Germany, which is where they used to have the right conditions all the time for these. But Brocken Spectre is...
They can look really quite eerie, can't they?
Yeah.
Have you ever seen one? I haven't.
No, I don't often go walking up mountains, to be honest with you. So,
I go walking up mountains, but not in the fog, so I've yet to see one.
We need the sun behind you to project it. But apparently, your brain can't quite work out what it is, so it looks enormous and imposing, your own shadow. So Brocken Spectres are a very curious name for what would you call it? A meteorological event?
Phenomenon.
A phenomenon, yes. A meteorological phenomenon. Gosh, there's a lot of syllables in that. So, which leads us on to weird names of things, Penny. Did you have one on dog days?
Yes, I did. You may have heard of dog days, particularly in the summer. I don't know if you've heard of them.
Yeah.
Do you know what they are?
I don't.
No.
It's Dog Day Afternoon, the film, isn't it?
No, I don't think it's got anything to do with the film, although I haven't seen the film.
Right.
So
I've read it in books.
It's from the Latin, and I'm not going to pronounce the Latin because I'm not very good at languages, but it literally was translated into English as puppy or dog days. And it actually came from the Greeks, who knew that there was a star called the Canis Majoris. I hope I've pronounced that correctly.
Yeah.
Which included Sirius, the Scorcher, and also the Dog Star.
Yeah.
So the last name reflects the way Sirius follows the constellation Orion into the night sky. Sirius is by far the brightest proper star in the night sky. Okay.
Yeah, you can always pick it out, can't
Yes.
you, on a clear night?
Yeah.
Oh, there's Sirius.
Yeah, exactly. Along with, several planets and things like that. But it caused ancient astronomers in Greece to take note of it around the world, including Greece. So in Egypt, its return to the night sky became known as a precursor to the annual flooding of the Nile and was worshipped as the goddess Sopdet. But it also became known as the precursor of the unpleasantly hot phase of the summer. So when we talk about dog days of the summer here in the UK, we're referring to those really oppressive, sultry, humid days that we get at the height of the summer.
Right.
And we might get, sort of a few of them before we have the classical thundery breakdown that happens with the Spanish plume, which obviously comes in from the south. So that's where the phrase dog days actually originates from.
Right, so it's nothing to do with wilting dogs or anything like that.
No, although
dogs don't like hot weather, so I guess they would wilt.
Yeah.
No, originally it didn't, but I do think, you probably will see some dogs sort of lying there panting and...
Yeah, it reminds me of Indian summer, which we've touched on before now.
We have,
And I always thought it referred to the subcontinent, and I can feel producer Clare's eyes boring into me now. So I will mention that an Indian summer is a sudden return to heat after the first frost. There we go. I've got a thumbs up. So I have learned something. But it actually comes from North America. And it should really be, Native American summer and not Indian summer. But yeah, so that's a misnomer that I was corrected on a few years ago. Anybody got any animal facts at all?
Oh, I can do animals.
Go on.
Except for snakes, maybe.
Go on, Indy.
So one of them might be ship's captains used to make detailed logs of their voyages around the world. And until about the mid-1800s, they weren't used for anything. They just got put into rooms and stored there. And then it was around about the 1840s, it was actually, the first meteorologists, although not necessarily known by that name, started thinking, well, actually, if we gathered all the information in these logs together, we could start working out what goes on in patterns around the oceans. They were mostly looking for sort of climatology, how strong is the current, which way is the wind blowing, can we find the trade winds, that kind of thing. But what they also found was that most of those captains also made a note of the birds and the animals and the other sort of things they saw. And they saw whales and they made a note of the whales. And they would find that at certain times of the year, the whales were all found in the southern Atlantic, and other times they were all found up near the Arctic. And they suddenly realised that whales were a migratory species, which they'd never known before then, because nobody had ever put all of the information together.
Interesting.
An odd one on weather and whales.
I've got some animal facts here. So has anyone heard about the frozen iguanas in Florida falling out of trees?
Yeah.
No.
Yeah, so this was a big thing in the news. Well, it has been a couple of times. I think most recently in January of this year. And actually the National Weather Service in America issued a warning that there may be falling iguanas from trees, but don't worry, they're not dead. And what happens is when it's particularly cold, they're cold-blooded animals, and they slow down to the extent that they become completely immobile, and poor things do drop out of trees. But hopefully most of them are able to recover fairly well. And then there's another one on a similar theme, which is about cricket. So you can tell the temperature by counting the chirps of a cricket. And this is something I've only just recently discovered, and it's called Dolbear's Law, named after Amos Dolbear, who was an American physicist and inventor. And he published an article in 1897 called The Cricket as a Thermometer. And he came up with a formula And if you want to work out the temperature in Celsius...
I was going to say, cricket's Fahrenheit or Celsius.
Yeah, well, originally they were Fahrenheit, but we've done the conversion here. So to work out the temperature in Celsius, you count the number of chirps in a minute, you add 30, and then you divide by 7. Or, if you're slightly less accurate but a slightly easier version, is count the number of chirps in 8 seconds and add 5. So that gives you the temperature.
It would be a shame if a frozen iguana fell on a cricket.
Wouldn't it?
Oh.
Yeah, that could well happen. Although actually I think that the cricket maths works better at temperatures between about 5 and 30 Celsius.
Right.
And probably the iguanas are falling out of trees maybe slightly below that temperature.
Right. So we've got a range of animals we can use there for various temperatures. Are animals used for anything else?
Well, they used to be. They used to use leeches to predict the weather.
Right, okay.
The very aptly named George Merriweather.
I was going to say, how did they point at the weather map?
Well. So yes, the aptly named George Merriweather invented something called the leech barometer, otherwise known as the tempest prognosticator, in which he used 12 leeches, each of which I'm afraid was stuck in a glass bottle. And the general idea was that as the pressure drops, the leeches climb the sides of the bottles and try and get out. Now, the bottle was stoppered, so they couldn't get out. But at the top, there was a sort of a tube with a hammer in it. And yeah, I know, it's not a big hammer. You have to think in miniature here. No, it's not going where you think it's going, Jeff. But essentially, they would sort of knock a lever, which you pulled something else, moved something else, and rang a bell in the middle of this sort of ring of bottles of leeches. The more leeches that climbed their bottles and rang their bells, the more likely there was to be a thunderstorm. George Merriweather actually tried to sell this to the government as a means of putting warnings out. Put one at every port, and then they can go and listen to the leeches. It didn't. I think the slightly more pun-laden version of saying that would be it didn't stick.
Very good.
Thunderstorms, anyone?
Oh yes, so there are 760 thunderstorms on Earth every hour, and actually this is a relatively recent scientific finding. Something we've been trying to calculate for many, many decades, but it was really only finally calculated in 2011, apparently, as a result of combining 40 weather stations around the world that were equipped with machines able to detect the electromagnetic pulses produced by strong lightning bolts. So, yes, we finally have a number. I think at some point we thought it was quite a few more than that, actually, but still 760 an hour isn't bad going.
Are they mostly in one part of the world?
Well, they're mostly in the tropics. And interestingly, where I read this fact, it says that they tend to occur mostly, or rather the peak time is around noon GMT. So that's interesting because I wonder why that would be. I'd have to get a few scientists together to think about why that might occur.
Yeah, that is interesting, isn't it? Because is it coming from observations or is it coming from satellite data?
Yeah, so it seems like this is coming from actual ground-based observations, but presumably, I think the reason is because satellite data can perhaps show the lightning strikes as a whole, but not necessarily cloud to ground or cloud to cloud. Different types of lightning strikes.
Yeah, I mean, I read an article, I think actually just this morning, that was saying that the next generation of satellite is going to be able to differentiate.
Right.
So we are going to get sort of extra information about lightning data.
Interesting.
Maybe mostly weather should go out and have an equatorial adventure and find out. See if
storm
we
chasing.
Get to the bottom of this one. Anybody else with thunderstorms?
Not particularly thunderstorms, but one that might be interesting is that the first meteor storm warnings were issued in 1861.
Right.
And they were really very effective. And in fact, they were so effective that the owners of the graving docks, now graving docks are where they used to bring damaged ships to have them repaired. rather than building new ships. But the storm warnings were so effective that the owners of the graving docks in Plymouth, where the damaged ships were taken for repair, actually complained about the loss of income because the storm warnings were so good that the ships weren't being damaged.
Right. Okay, that's interesting. So has anybody else got any more storms?
Penny, you're waving?
Yes, I do indeed. So here is a stunning UK factoid for you. Summer is the most thundery time of the year. Da, da, da. So more thunderstorms occur during the summer than at any other time of the year. Do you know why?
It's hotter.
Heat.
Yes, it's all to do with heat, as the warmth of the summer sun provides the perfect conditions of rising air and moisture required for the creation of thunderstorms. And where are they most likely to occur in the UK?
Southeast.
Oh,
we say in tandem.
Oh, that was
Wow.
wonderful.
Stereo.
Yes, East Midlands and Southeast England. So we can all remember, just thinking back to July 2021 when we had that massive thundery event over London, where we had, I think it was over 40 millimetres in an hour.
Right. Okay.
And they had surface water flooding. And that was right on the edge of the low pressure system that brought all that devastating flooding to Belgium, the Netherlands and Germany.
So was this part of a Spanish plume, which I think you mentioned earlier? Or because did somebody want to go in and describe a Spanish plume? That would be
The two forecasters look at each other in fear.
I'm happy to, but
So as far as I remember, this is a block of warm air that comes up from the Iberian Peninsula.
Well, you've got 3 levels up through the atmosphere.
Mm-hmm.
So the first level is sort of very moist air, very warm air, generally sitting over the southern part of the UK.
Right.
And then you get some hotter, dry air, which has been sat over the high sort of ground of central Spain. That comes up on a southerly wind.
Right, so that moves over the...
the very warm, moist air. And then you have, coming in from the west, normally with a cold front coming in from the Atlantic, you have much colder air in sort of the top half of the atmosphere.
Right, okay.
So when the very warm, moist air is warmed up, sort of under the summer sun, which is trapped under the hot, dry air. When that is warmed up and it breaks through that hot, dry air, because you've just got colder, moister air above it, it just goes
bang.
Bang. And you get those huge, towering cumulonimbus clouds. And then sometimes you get alticumulus castellanus.
Oh, that's really cool when you see that.
Alticumulus flocus as well. And those result, in those really magnificent, spectacular thunderstorms, which are just so intense, so torrential.
Yeah, and of course, once it's all passed through, you might end up with cirrus passatus cumulonimbus.
Wow. Of course.
Well, Jeff,
and also
now you're showing off.
Would you like to translate that for us?
So there's a thing in the thunderstorm called the anvil, which is the highest point. It looks like like a blacksmith's anvil, and it's made of a very high cloud called cirrus. When it breaks off, once the thunderstorm has died away, you could be left with a very dense patch of cirrus, which is cirrus passatus cumulonimbus. So,
and he gets it in twice.
There you go.
So, Penny, your fact was about thunderstorms being most common in summer, which I think may or may not surprise people, but associated with thunderstorms is hail often, isn't it?
Yes.
And sometimes that really does take people by surprise in the summer because it's a frozen precipitation.
Yes.
But
and you're going to ask me how hail is formed, aren't you?
Well, do we know? Do we know how hail is formed?
It's cloud condensation nuclei, isn't it? It's a small speck of dust or something that starts it all off, and water accumulates around the condensation nuclei. Yeah. Because of the extreme thermals within
updrafts.
Updrafts and downdrafts.
And downdrafts.
The water drop goes up through the freezing level and freezes into a small ice pellet and then comes back down into the liquid water. I'm loving the diagram. Thank you, Penny. comes back down and repeats that several times. So if you ever cut a hailstone in half, you'll see layers like an onion of evidence that it's been up and down through and it's only when it becomes too heavy for the updraft that it actually falls to the ground.
And that's when you can get those absolutely enormous hailstones, particularly in the States when the updrafts are incredibly strong.
So, I mean, there's lots of footage on YouTube of people's swimming pools and things, being absolutely destroyed and trees and that sort of thing.
But even in this country, there was the Ottery hailstorm when it was just a very localized event with some decent sized hail, but an awful lot of it. And you look at the pictures, it's like snowdrift.
It does really look like snow. Yeah.
It masquerades as snow, doesn't it?
Yeah.
In the height of summer.
Yeah. It does, But and obviously the stronger the updrafts, the bigger the hail can grow. So
that's right. And not only hail, but obviously with the downdrafts, you can get huge microbursts.
So microbursts is where the air comes down with the hail. And is in spreads out. Your miming is wonderful. So this is terrifically dangerous for aircraft because even when they're trying to climb through a microburst, the air is coming down, and it can come down so fast that no matter how much they pull back on the yoke, they are not going to climb. No. And has been the cause of a few accidents. But we're well aware of it these days.
Yeah, so I think, thunderstorms are, they're so well known, aren't they? Because not only do you get heavy rain, you get hail, you get the very squally winds, possibly even microbursts, but, you can also get tornadoes over the land as well as water spouts over the sea. Yeah,
but fascinating. We get to the whole episode there just on... Just on that. And this is why aircraft don't fly through thunderstorms unless you happen to work on a research aircraft, and then you seem to head for them for some reason. I don't know why, because it looks interesting. But of course, the other fact is that most rain starts as snow and just melts on the way down. And it's only in the winter when it fails to melt that you actually get snow on the ground.
If it's cold enough, yes.
Yeah, so...
Yeah, because I guess you could assume it was the other way around, that most... snow starts as rain and freezes on the way down, but that's not the case. It can do.
Extreme examples.
And I guess you can get freezing rain, which is very dangerous.
And I think that's what groundpool is. Isn't it? It's rain that's frozen around a snowflake.
Groundpool, yes, and then proper freezing rain is when the rain falls as liquid water, but then freezes on impact with an extremely cold surface, and that's when you get that black ice.
Yeah.
We had instances of it in Beast from the East a few years back.
And they get, I think, I can't remember where it was now, but it was somewhere in Europe next to a lake where the wind comes off the lake and blows the lake water, and it freezes instantly. Yes. And it's like 2 foot thick on cars and things that are parked along the lakeside, So
I remember we had some freezing rain here in Devon. What
we did
a couple of years ago?
Yeah, that was 2018
because it was literally it was sheathed over my car, and it was great fun trying to get into it.
It's almost impossible, isn't it, to do anything about it or with it?
You just have to wait until it melts. You really can't get through it.
So, touching on snow, did we have a fact about snow?
I've got a snow fact. Snow isn't actually white, would you believe?
No.
So it's translucent. It very much appears white, and we even call it the white stuff. But it is translucent, and the reason it appears white, as many of us will know, white light is when all light colours are combined. And so what happens in a snowflake, which has many sides and many surfaces, all the light is scattered in many, many directions, diffusing the entire colour spectrum, and it makes it appear white to the human eye. But translucent Christmas maybe doesn't have quite the same ring to it.
No, it doesn't really.
Isn't it true that polar bears are not? I was going to say polar bears are translucent, but they're not.
Their
fur is translucent.
And haven't they got black skin, or am I
They
making
do have
that
black
up?
skin.
Yes.
That's to do with keeping them warmer. Yes.
Yeah, was it? Oh, right. I did not know that. The Arctic is named after the bear. The Latin for bear, and
Well, and that leads me on nicely to my Antarctic fact, which is that it almost never rains or snows in Antarctica.
Oh, it's
There's
a
lots of
desert,
stuff there.
isn't it?
It's a desert, that's right,
Yeah.
Catherine, and it's actually one of the driest deserts in the world. So there's very rarely any precipitation there. But of course, when it does snow there, it doesn't melt. It stays there, and then more snow falls, and it compacts, and then you get the ice that we're all very familiar with. But it takes us back to that perhaps fairly familiar old adage of it being too cold to snow. And that's kind of the reason why it doesn't in Antarctica, because you do need humidity to produce precipitation, and humidity needs some kind of heat. So that's why it's so rare that it snows. It's not often that it's too cold to snow in the UK though. So yeah, not quite so apt for us.
Yeah, so I mean, this is the definition of a desert, isn't it? That it's lack of precipitation rather than extreme.
That's
hot
right.
temperatures.
Yes, I guess because you immediately think of sand dunes when you think of deserts. But yes, Antarctica is also a desert.
I wonder if that's why the penguins went there.
Because the weather's
doesn't
nice.
great.
That's a desert.
It's better than the Arctic where the polar bears are.
Yeah, they've got it made down there.
Tell that to the emperor penguin spending the winter there.
I've got a penguin fact from the Falkland Islands,
Excellent.
Okay.
and it's that they don't fall over when aircraft fly over them.
Oh.
So this was a myth that was spread
That you
by
experimented with.
yes, me and the RAF. We spent many a time. This was a myth that was spread around by some scurrilous newspapers that they were spent so much time watching the planes going over that they fell over backwards because they don't normally see that sort of thing. But it's not true. What is true is although they look very pretty, penguins, they stink. So that's, they are very smelly indeed when you get close to them.
Well, do you think that they've got a fear of snow? Do you know what a fear of snow is called? Just found out.
No.
Again, it originates from the Greeks.
What do they know about snow?
They had snow in
had
Athens,
snow?
didn't they? Yes. When did they have snow in Athens? It was it last autumn?
Yeah.
Autumn 2021. 2021, yes. Well, so did you know that there's a phobia of fear of snow?
No.
No.
So you have the Greek word phobos for fear, phobia, that we use. And I'm hoping I'm pronouncing this correctly. Kion, meaning snow. So it's kionophobia is the fear of snow, being afraid of snow.
Didn't know that.
No, that's new.
So there you go.
Right. Okay.
When do you think we see snow most of all? Is it at Christmas or at Easter in the UK?
I'd always... Well, it's not a Christmas, is it? Because Charles Dickens essentially invented the White Christmas, and it didn't really happen. It was an unusual event when he wrote about it.
Yeah. So you're more likely to see snow at Easter than at Christmas in the UK.
Okay.
But of course,
Easter moves, though.
Yes, exactly. Christmas is always the 25th of December, but Easter is a movable feast. So the earlier Easter happens, say
Logically,
in March
yes.
or early April, then yeah, you're more likely to see snow. But if it's sort of, like this year, what was it? I can't even remember.
Mid-April.
Or even the end of April, you're more than likely not going to see snow.
Right.
So
I know that we always tend to get hail just as the blossom comes out.
Yes.
Yeah, and it strips all the blossom
And
off the
strong
trees.
winds, yeah.
Yeah. But,
Yes, if the magnolias are out, you can guarantee there'll be a gale within a week.
Yeah, no, absolutely. But yeah, so snow is most common in January and February in the UK.
Yeah, I know because my birthday's in February and I always associate my birthday with snow. So, yeah, and that makes me happy.
Oh, good.
Right, so quick fire round. Who's got any remaining facts?
And I can do now for something completely different. This is not about snow.
Excellent.
Well, maybe.
Does it involve the Greeks?
It's not about the Greeks either.
Okay. Fire away.
We are coming forwards in time. So how about the fact that the very first computer that the Met Office used for testing their numerical weather productions. This isn't to do with making the operational forecast. This is the early days. Let's test it. Let's see if we can do anything with a computer. That computer belonged to the catering firm Lyons, who were famous for their tea shops and
Cakes.
Yes, Lyons cakes, exactly, cakes and biscuits. Now, Lyons themselves were a very forward-thinking company, in the 1950s, by thinking, now, if we build a computer, we can put our accounts on it, and this is going to make us, really effective. Now, that's pretty good going. So the Met Office went, can we borrow your computer to run some of our calculations on? And it meant that as they started experimenting with producing forecasts, Lyons could then use those weather forecasts to decide what they were going to send out in their fresh produce vans.
Oh,
So the idea of sending, the Met Office sort of forecast affecting what supermarkets put on the shelves is nothing new.
No,
It's fantastic.
But we still do that today, don't we? We still
do.
produce forecasts for retail and, explaining if it's going to be a hot barbecue weekend or a one to get the soup in.
Yeah, absolutely. Back in 1951, they started doing that with our forecasts, even if it was informally. So
It's
yes.
incredible.
Just down the road from the Met Office is one of these big warehouses that sells all sorts of stuff like barbecues and curtains and all that sort of thing. I won't name the name. And I wandered in there one day with my Met Office polo shirt on.
That was a mistake.
and was looking at the barbecues, only to find that the manager was behind me putting the prices up as I wandered through. So I've got a fact for you. Buys ballot law. Who knows what buys ballot law is? Come on, forecasters.
Even the archivists heard of that one.
Yeah.
It's really good though.
It is.
It's a brilliant.
Buys
brilliant.
ballot law
Brilliant.
is really useful to know. Well, not at all useful to know if you're a member of the public, really. But if you stand with your back to the wind in the northern hemisphere, the low pressure area is on your left.
And the high pressure
Is on your right. Yeah.
Yeah.
So that's useful for everybody. Who knows who buys ballot what? Well, his name, let's see, it's a double barrel surname, buys ballot. It's just one person. It's not like Rolls Royce, two people like I'd assume. He was christened Christophorus Henricus Didericus buys ballot.
Wow.
So
Wow.
yeah, I'm going to have to get a few more names now to beat
Yeah.
that.
Yeah, even more than you, Jeff.
And Latinise the ends of them, of
And
course.
Jeffficus. I quite like that. Yeah. So right. Next fact.
Oh, okay, I've got one. So the total mass of the Earth's atmosphere is about 5.5 quadrillion tons, which sounds a lot, but it's roughly only 1/1,000,000th of the Earth's mass. And if you have a normal-sized globe, then the atmosphere would be just 2 coats of varnish on top of
Wow.
On top of a
Wow.
desk.
Only 2
desk
coats
globe.
Yeah.
on a desk globe.
Hmm.
Wow.
That's amazing though.
Yeah.
So we're just sort of holding all that weight up, aren't
Well,
we?
that's the thing. I mean, air is really quite surprisingly heavy.
Mm.
So at the moment, we've all got the weight of the atmosphere weighing down on us. And the reason we don't feel it is because the atmosphere is fluid. And so you've got air pushing in all directions. So if you hold your hand out in front of you, you've got something like 10 bowling balls worth of weight of air pushing down on your palm. But equally, you've got air pushing in all directions. So it's a funny concept, isn't it, to think of all that weight around us.
And of course, we're designed to cope with that sort of that force to an extent as
Yes.
well, aren't we?
Yeah,
Yes.
because it's inside your body as well.
Yes, exactly.
Yeah, it's like although low pressure is associated with inclement weather, the fact that you've got a few less tons of atmosphere on top of you when you wake up with a low pressure on you should make you feel better.
It should,
But
shouldn't it?
But then you've got the dark clouds and the rain and the strong winds just to...
Just to bring you back down to earth again.
I've got one. Fog clearance. When does fog clear?
Oh, yes. This is another good sort of
This-
vice ballot
so
type rule,
this
This
isn't
is
it?
a
Yeah.
good one.
Yeah.
This
a
is
good one.
there's all sorts of caveats associated with this one,
Yes.
isn't there? So if fog is going to clear in September, the 9th month, it will clear at 9 o'clock. In October, the 10th month, it will clear at 10 o'clock, and so on until midday in December. Midday in December.
And then what happens in January?
Then you have to go backwards, and that's a lot of maths.
Yes.
So.
But it is a really handy just rule of thumb, isn't it?
It is. Yeah. And the other one is if you can see the sun or not.
Oh, really? I don't know.
Yeah. So if you can see the sun through the fog.
So that's shallow fog then.
Could be.
Oh, right.
Or it could be that it's clearing, maybe.
Not necessarily.
Yeah, not necessarily. Then it means that I think it'll either clear within the hour or 3 hours. I can't remember which. Which is not very good, is it? So if you can see the sun or blue sky, it will clear. If you can't see the sun or blue sky, then it might not clear.
Yeah. So we have colour states, don't we? That on
the military.
In the military, they describe this. And I remember somebody I knew once got a phone call from an RAF person and said, "When can we go flying?" And he replied with, "Can you see the hangar?" And the guy said no. He said, "When you can see the hangar, you can go flying." Which is not the customer service we... I've got another fog fact. Some people capture fog to get the water from it. So this is areas where it's particularly dry. And the one I'm thinking of is the Atacama Desert in South America. And what they do is they set up a mesh, like in a frame, only by a meter, but several of these. And as the fog drifts through, because they don't get rain from anywhere else because of just the situation they're in, the mesh actually helps to coalesce all the raindrops, and then that falls down and they capture it, and that's how they can produce water from fog. So they have fog capturing devices.
How lovely!
Very clever.
Yeah.
I wonder if they borrowed that idea from the cacti, because it's just in the plants in those situations, of course, depend on exactly the same thing. They depend on the water landing, the fog essentially collecting on the spines. And,
so they have those little
condensing.
hairs, don't
Yes.
they? Oh, is that where it came from?
I don't know, but maybe it's logical. Perhaps you might borrow it from nature. We've borrowed so much from nature.
They should have copyrighted it. Any more last minute facts?
So I've got one about observations. Now this really is quite niche, but those of us in the Met Office know that we take our daily observations, which are used for sort of climatology, at 9 o'clock in the morning. And it's never occurred to me to question why we do that, because it would kind of make more sense to maybe do it either at midnight or midday. And apparently, and I can't corroborate this or find any evidence, but I've been told that the reason is in the very early days of weather observations, a lot of them were taken by lighthouse keepers, and they just said they were too busy at midnight. I'm sure they had lots to do to keep things going.
Well, I would imagine trying to do an observation with a lighthouse is quite difficult, because you'd be like, right, what's it look like? Oh, no, it's gone dark again. Can we just stop the
good
lights
point.
for a
Maybe
second?
doing it in the daylight makes
Can we switch
much
the
more
light
sense.
off?
Yeah, I think that's probably right, isn't it? That it was a time that you were always going to be in the daylight.
Yeah.
Because the other thing I thought was people working at night time, you're not going to be doing that so much, are you?
Yeah.
And the chief meteorologist gives a briefing at what time every morning?
9:05.
And nobody questions why it's 9:05 until they come in from outside and say, why 9:05? And all we can say is, it's as good as any other time, really.
Because it is.
Because it is, yes. And that's it for this episode of Mostly Weather Random Facts. Our thanks to Helen Roberts, Catherine Ross and Penny Tranter. I'm Jeff Norwood-Brown, and this podcast is produced by us, the Mostly Weather podcast team. The series producer is Clare Nasir, and our editor is Simon Hammett.
Mostly Weather is a podcast by the UK Met Office. For the latest weather conditions where you are, download the Met Office weather app.